Imagine a place where the laws of physics simply cease to exist. A place so powerful that not even light, our universe's fastest traveler, can escape its grasp. If you fell into it, every atom of your body would be stretched, twisted, and shredded into oblivion. And yet, at the very same time, this monstrous cosmic predator might also be the key to unlocking the deepest mysteries of space and time itself. These are the monsters of the universe, black holes. They lurk in the darkness, invisible, silent, waiting. But their presence is betrayed by the destruction they leave behind. Whole stars vanish, their screams turned into radiation that races across the cosmos. And at the center of almost every galaxy, including our own, one of these cosmic beasts reigns supreme. But here's the most terrifying truth of all. We still don't fully understand what they are. Once upon a time, black holes were nothing more than a mathematical curiosity, a strange prediction that even Einstein himself refused to believe. In 1916, Karl Schwarzschild, a German physicist serving on the front lines of World War I, wrote to Einstein. He had solved Einstein's new equations of general relativity and discovered something astonishing. A point in space where gravity would become infinite. A point where space and time would fold in on themselves. Einstein thought it was absurd. How could nature allow such a thing to exist? And yet, over a century later, the universe has proven him wrong again and again. To understand the terror of a black hole, imagine a star. Not our gentle sun, but a massive one, 10, 20, or even 30 times larger. It burns furiously, fusing hydrogen into helium, releasing unimaginable energy, holding itself together against gravity's relentless pull. But eventually, even the mightiest stars run out of fuel. And when the nuclear fire in their cores flickers out, gravity wins. The star collapses in a titanic explosion, a supernova. For a few seconds, it shines brighter than an entire galaxy. And what remains after the chaos is either a dense neutron star, or if the star was massive enough, something far darker. The collapse continues until the core's matter is crushed into an infinitely small point, a singularity, surrounded by an invisible boundary known as the event horizon. Cross that line, and there's no coming back. At that singularity, our understanding of physics breaks. Space, time, energy, everything we know, disappears into an unknown abyss. If that sounds terrifying, it gets worse, because black holes don't just sit there, they feed. Picture this. A star strays too close to one of these invisible beasts. The immense gravity grabs it, stretches it into a long, glowing noodle of plasma, in a process astronomers call spaghettification. Half of the star's material spirals inward, vanishing forever. The other half is flung outward at nearly the speed of light, forming brilliant jets that shoot across space for thousands of light years. We can't see the black hole itself, but we can see these cosmic tantrums, the evidence of its insatiable hunger. Some of these feeding frenzies are so powerful that they outshine entire galaxies. They're known as quasars, and at their hearts lie supermassive black holes, millions or even billions of times more massive than the Sun. But how do such titans form? That is one of the greatest mysteries in astronomy. The black hole at the center of our own galaxy, Sagittarius A, is about 4 million times the mass of the Sun, and yet, compared to others in the cosmos, it's small. In the galaxy M87, 55 million light-years away, lies a monster over 6 billion solar masses. In 2019, humanity saw it for the first time, the now iconic orange ring of fire captured by the Event Horizon telescope. That faint, blurry image wasn't just a photograph, it was a window into the unthinkable, proof that these cosmic monsters truly exist. But here's where things get even stranger. For all their destructive reputation, black holes might also be the architects of galaxies. Astronomers believe that the formation and growth of black holes are deeply tied to the creation of stars and the structure of the universe itself. The same force that devours might also create. And yet, there's an even more mind-bending idea. What if black holes aren't the end of matter, but the beginning of something else? Some physicists believe that every black hole could be a portal, a bridge to another universe. When something crosses the event horizon, perhaps it doesn't just vanish. Maybe it re-emerges on the other side, in a new universe born from the ashes of the old. In this view, our own universe could have been born from a black hole in another cosmos, an infinite cycle of creation and destruction, where every death gives birth to something new. Of course, that's still theory, but in the strange world of quantum mechanics, where particles can exist in two places at once, and information can never truly be destroyed, even the impossible begins to sound plausible. Speaking of information, Stephen Hawking once proposed a paradox that shook physics to its core. If nothing can escape a black hole, then all the information about what fell in should be lost forever. But according to quantum mechanics, that's impossible. Information cannot simply vanish. This contradiction, known as the black hole information paradox, is still unsolved. Hawking later proposed that black holes aren't entirely black. They slowly leak energy in the form of what's now called Hawking radiation. Over unimaginable timescales, they could evaporate completely, leaving behind nothing. But where does the information go? Does it somehow remain encoded in the radiation? Or is it preserved on the surface of the event horizon, like a cosmic hologram? Some scientists now believe our entire universe might behave like one giant hologram, three-dimensional reality projected from the two-dimensional fabric of space-time itself. If that's true, then black holes might hold the secret to everything. But these monsters aren't just far away. They could be closer than we think. Astronomers estimate there are millions of black holes wandering through our galaxy, silent and invisible. Some may be just a few dozen light-years from Earth, completely undetectable until something crosses their path. And when two of them collide, they send ripples through the fabric of space-time itself, gravitational waves, first detected in 2015. Each detection is like hearing the universe whisper its darkest secrets. And those whispers tell us something astonishing. Black holes can merge, grow, and evolve, just like galaxies, just like stars. They are not static. They are alive in a cosmic sense, shaping the very structure of the universe. So what happens if you fall into one? Let's imagine. As you approach the event horizon, time itself slows down. To an outside observer, you'd appear to freeze in place, fading slowly from view. But from your perspective, you'd fall through unhindered, past the horizon, into the unknown. No one knows what lies beyond. It could be instant death. Or, as some theories suggest, you might find yourself somewhere entirely new, a different region of space-time, or another universe altogether. It's the ultimate cosmic riddle, a doorway that only opens one way. Black holes are the universe's paradox, creatures of destruction that may hold the key to creation. Born from death, they reshape the cosmos, govern galaxies, and challenge everything we think we know about physics. They are both the monsters and the mysteries of the universe. And perhaps one day, when we finally understand them, we'll discover that these cosmic beasts weren't monsters after all, but the architects of everything we see. Until then, they remain there, silent and invisible, patiently waiting in the dark, watching, and reminding us that the most terrifying thing about the universe is how much of it we still don't understand.